because there's more repulsion up here, so it's going to be less than 109.5 degrees. Now, that being said, if we wanted to know the actual bond angle, we could look it up. We could look up the bond angle in pH3, okay? We could look up an actual value. But just generically, we can call it less than 109.5. Okay, what's the next one?
H2SE.
H2SE. All right, central atom will be the Se, selenium. Okay, so you might start by drawing it something like so. How many electrons do we get? 8 total electrons, 6 from the selenium, 1 from each hydrogen. So how many pairs would that be? 4. So 4 pairs. Where do I start with them? On the bonds. So I use 2 pairs for that. I have 2 pairs left. Where do they go? The one at the hydrogen. Hydrogen's already good. It has the 1 bond, it's done. So put them on the central selenium. Does everything now have an octet? That it does. It has an octet. Okay. How many groups are on the central atom? 4 groups. 2 lone pairs, 2 bonds. So still 4 groups. What does that tell you about the electron pair geometry? It's going to be tetrahedral. It's going to be tetrahedral because there are still 4 groups of electrons on the central atom. So that's tetrahedral. Okay. But now we only have 2 atoms. We only have 2 atoms. So go back to your structure. Go back to your structure. We've already taken 1 atom off from the previous one. Doesn't matter which of these 3 we take off now. It won't, because they're all the exact same distance away, angle away from the lone pair. So take another one off. Again, it does not matter which one. Okay, so notice this, the basic geometry has not changed, but now my molecular geometry is only these atoms that you see here. We've seen something like this already. What do we call this? We call this bent. Okay, we call this geometry here bent. So the molecular geometry is bent. And what would the bond angle be, ladies and gentlemen? Less than 109.5. So notice this bond angle is different from the other bent geometry because the basic electron pair geometry has changed. Previously we were trigonal planar and that was 120, so less than 120. This is tetrahedral, so 109.5, now less than 109.5 because these lone pairs are going to squeeze these atoms down just a little bit. So less than 109.5 degrees. All right, we're going to stop here for today. We'll pick up the rest of it tomorrow. Here's what you guys need to do with this stuff, okay? The point of this is not to have to memorize all this stuff. For example, memorize, okay, if I have 4 groups of electrons in the central atom and 2 atoms, then I have a tetrahedral electron pair geometry and a bent molecular geometry. You could do that, don't get me wrong. I've had students do that, and you can do that successfully. What you really want to be able to do, though, is given this Lewis structure, or after having drawn the Lewis structure, you want to be able to visualize these shapes. You want to be able to see them. That's why I have you build them. The best, absolute best way to study this stuff here is to get yourself something that you can build this stuff out of. Don't have to be styrofoam balls. Styrofoam's kind of expensive, by the way. Buy yourself some candy, okay? And stick toothpicks in it, okay? Be able to build it and see it yourself. That's the best way to study this stuff. And then from there, be able to name it, okay? That's what you want to be able to do. All right. So you guys can bring your styrofoam balls and toothpicks back up here, and we'll do the rest of them tomorrow.
The thing keeps falling.
That thing should tighten.
Oh, it can. Just leave the whole.
This here?
Yeah.
See, now it's tight, now it doesn't want to go.
Oh.
You loosen it, now it goes up and down.
Okay. That.
I made the wrong choice for my videographer.
Yeah, you might have.
Alright. Oh, you're still recording?
Yep. Yep.